My name is Sabela de la Torre, and I'm part of the EGA team in Barcelona, led by Jordi Rambla, who couldn't finally manage to conduct this webinar himself. So today, I will do a brief introduction to the Beacon project. Then I will review the Beacon API, the development, the deployment of the Beacon, and finally we will have time for some questions. So, what is a Beacon? It is a discovery service for genetic variants. The aim of the project is to develop tools to make data discoverable, to encourage and help in data sharing, and to increase the efficiency in data access process. For example, a Beacon can help you to decide if a specific dataset is relevant for you without having to request access. Without the Beacon, you might apply for datasets which maybe are not relevant for your research, with all the waste of time that this implies. A Beacon answers questions like, have you observed this allele at this position on this chromosome? In this picture, you can see the ELIXIR beacons that are currently up and running. There are 6 nodes involved in these beacons, and there are some other nodes that are working on deploying their first beacons. Now, I will talk about the API history of the Beacon. And the Beacon project started a few years ago, and in 2014, the version 01 was presented. It was very simple, and in 2015, the version 02 was presented, and it was more complex. It had more kinds of answers to fault overlap loop. It also managed datasets and a simple version of the data use conditions. It was not very well adapted and not polished enough. Last year, we presented the version 03, which simplified in some way the 02 and improved, for example, support for datasets and allowed to query multiple datasets. It was more modular and extensible, and it also included some improvements to the data model. In this link to GitHub, you can see the specification of this version. Since then, we are working on version 04, which is still in progress. It will include support for complex variants, for example, duplications or deletions. It will include improved data use conditions, which are consent codes in Adam. It will also include some documentation and minor improvements. The definition will be moved from agro to proto-buffers, and a test suite will be provided so the developers can easily test if their implementations are compliant with this version of the API. And it will also include a centralized list of errors, codes, and messages. The future, there are these are some of the tasks that we want to do. We want to stabilize the API. We want to implement the 3-tier access, public, registered, and controlled. We want to implement the AAA for the registered level and extend the query language to support data use conditions. We also want to cover the range queries. And last but not least, we want to define the Beacon network API. This work is already ongoing. One of the ideas of this network is to have a registry of beacons, so you can query directly to the registry instead of querying each beacon one by one. Next block is the development. So the application has been developed using Java 8 and Spring Boot framework, and we use Hibernate for communication with the persistent layer. For testing, we've used JUnit and DBUnit. In the pictures, you can see the structure of the project. On the right, you can see the packages of the project. The controller package contains the main classes, well, the entry points of the application. Here you define the endpoints that you want to publish and you want to listen to. Then in the DTO package, you have the Java objects that are received or sent by the application. In the model package, you have the Java classes that represent the database tables. And in the repository package, you have the functions that allows you to interact with the database, to query the database. And finally, the service package, there you have the functions, well, the actual work of the application. I mean, and in the service, you implement the real code that does the work. And in the other picture, on the left, on the bottom left, you have the resource folder, which contains the application property files and also the log4j configuration. These application properties files are used to customize the application. In the application.properties, you have the information about the beacon and the organization that controls this beacon. So if you want to deploy your own beacon, you have to change this with your own information. And in the application.yaml, here you can specify three examples of queries that work for your data. For the data persistence, we've used the Postgres database, but any other SQL database should work with small changes in the property files. And the schema, currently the schema of the database is very simple. Here you can see it. It just contains 2 tables and 2 views. The application publishes 2 endpoints. The main endpoint is the root endpoint, which returns information about the beacon and the organization that has published this beacon. In this example, you can see that in the first part you have the organization information, and then below the information about the beacon itself, welcome URL, and some other stuff. And you also have the list of datasets that this beacon is querying or can query. And the other endpoint is this one, the /query. With this endpoint, you can actually query the beacon, and it has some parameters like the position, the assembly, the reference name, which is the chromosome, and you can also include the allele that you want to query about, and that's it. And on the right, you can see an example of the response. It will answer with an exists true or false at the beginning. And about the deployment, well, the backend has been developed with Java, so you need Maven and Java to compile and package this application into a jar. You need a Postgres database in your system and a space for deploying this jar. Remember that the Postgres database must be accessible, must have connectivity from the Java application. And we also developed a front end, which you can find in this URL, which is developed with AngularJS framework. So you need Node.js to compile it, and a web server like Apache to share the application. But we also have provided another way to deploy your beacon, which is using Docker images. What is Docker? Docker is a tool designed to make it easier to create, deploy, and run applications. the main purpose of Docker is to eliminate the so famous, so well-known sentence that works on my machine. And how is this done? By providing a uniform wrapper around the software package. Here you can see a picture, the difference between shipping a whole virtual machine versus shipping a Docker image. As you can see in the Docker case, you don't have to include in the image all the operating system. You just need the binaries and libraries required by the software inside the Docker image. And so, as I said, well, we have these Docker images, and we have two options for doing this. In the first URL, you can find a Docker image which contains the Java application and the database inside the same container. In the second option, if you follow the instructions in this URL, you can build a container with the Java application, another container with the database, and another container with the user interface. And in the picture below, you can see the appearance of this user interface. And that's all. I think I've been very quick. If you have any questions?